Hey there, we're looking at some of the homework problems in this section on partial fractions. The first problem that we have wants us to write out the form of the partial fraction decomposition of the following function. And we have x to the power 5 plus 9 divided by x squared minus x times x to the power 4 plus 6x plus 9. So what I want to start doing here is actually just look at a couple of the terms in the denominator here. Specifically first, let's look at the term x squared minus x. Before you start any decomposition, you want to make sure that A, you're working with a proper fraction, which in this case we are, and B, that the denominator is completely factored, which in this case it's not. So the x squared minus x can further factor into x times x minus 1. And then also if we look at the other factor, the x to the power 4 plus 6x to the power 4, 6x squared plus 9. This is a type of a function that we call a kind of a quadratic wannabe. So really we want to write this as x squared, quantity squared, plus 6 times x squared plus 9. And I'm going to say, just to make this a little bit easier to see, let's let y be equal to x squared. So if we make this substitution, really this is just y squared plus 6y plus 9. And now we can see this is actually a perfect square. This will factor into y plus 3 quantity squared. And then lastly, let's just back substitute so we get this thing back in terms of x. So we could write this as x squared plus 3 quantity squared. All right. So let's quickly go ahead and just rewrite this expression. I'm going to write this as x to the power 5 plus 9 divided by x times x plus 1. Oops, that was not a plus, that was a minus. Sorry, that was a minus. X minus 1. And then x squared plus 3 quantity squared. All right, so now that this guy is completely factored, we can now go ahead and write this in its factored form. So if you look at the factors in the bottom, we're going to have an x, we'll have an x minus 1, and we will have the x squared plus 3. But because this term has duplicity of 2, we are going to write it twice. So x squared plus 3 squared, and then x squared plus 3 just to the power 1. And this is due to the power rule of partial fractions. All right, so my numerators are going to be a. Again, if you note here, x has degree 1, so the numerator has to have degree 0. The same thing for the next term. This will be b over x minus 1. But do note that now this term, even though it has duplicity 2, the inside has a degree 2. So therefore the numerator is going to be cx plus d. And then the numerator for this last term will be ex plus f. All right. Problem B is similar. And again, this is asking for me to give the partial fraction decomposition. Again, what's really important in this problem is that we note that the degree of the top and the bottom are the same. So that means that this is not a proper fraction. So to start this problem, I would like to perform long division to turn this into a proper fraction. So my divisor here is x squared plus x minus 12, and we are dividing x squared. I'm going to put in those missing terms, plus 0x plus 0. All right, so here we go with long division. The question that I ask myself is, what do I need to multiply x squared by to get x squared? Answer is 1. 1 times x squared is x squared. 1 times x is just 1x. 1 times negative 12 is minus 12. and we subtract. 0 minus 1 is -1, so I get negative x, and then 0 minus -12, I get plus 12. All right. So if we use the remainder theorem to write this, this is going to be equal to 1 plus negative x plus 12 divided by x squared plus x minus 12. All right, so we can see that the denominator factors for this last term, and actually make life a little bit easier, let's write this as 1 plus, actually I want to write it as 1 minus, we can just write this as x minus 12 over x squared plus x minus 12. All I did was factor a negative from the numerator. And now we see that this can be written as 1 minus x minus 12 over x squared plus x minus 12 factors into x plus 4 times x minus 3. All right. This is going to be equal to 1 minus, I will keep this piece in brackets here. So the expansion here is going to be a over x plus 4 plus b over x minus 3. So this problem specifically says that we don't need to solve for a and b. This is really all that it wants. And you can certainly leave your answer here. If you distribute the negative, this could be written as 1 minus a over x plus 4 minus b over x minus 3. But remember that both a and b are arbitrary. And so really we could put the sign with them. So it would also be correct to say that this would be 1 plus a over x plus 4 plus b over x minus 3. All right. The next problem here wants me to evaluate the following integral, and this is the integral of 3t minus 2 divided by t plus 1. All right, so problem recognition is really important here. We're finding the integral of a rational expression, so that is a polynomial divided by a polynomial. We see that u substitution does not work. So we really want to see if we can expand this thing. Since this rational expression is this is an improper fraction, the degree of the top is equal to the degree of the bottom, we need to do long division first. So I'm going to go ahead and write that over here. We're dividing by t plus 1, and we're dividing the term 3t minus 2. All right, so the question is, what do I need to multiply t by to get 3t? We multiply by 3. 3 times t plus 1 is going to be 3t plus 3. And now we can subtract. All right, 3t minus 3t is 0. Negative 2 minus 3 will be minus 5. So this is my remainder. 5 is my remainder. Again, using the division algorithm to write this gives the integral of 3 minus 5 over t plus 1 dt. All right, and now this thing is in a form that I know how to integrate. So the integral here will be 3t minus 5 times the natural log of the absolute value of t plus 1. And then don't forget that plus c on your final answer. All right, the next problem that I have here is asking me to make a substitution to express the integrand as a rational function and then to evaluate. I'm going to start by substituting u to be equal to e to the x. So let's start here by saying, let's let u be equal to e to the x. So it follows then that du is equal to e to the x dx. I can see that in my expression, I am going to have to solve for, if we rewrite, this is the integral of 1 over 9 plus e to the x dx. I would like to solve for dx also. So you can see here that dx is equal to 1 over e to the x du, which we can also write since e to the x is equal to u. So dx is equal to 1 over u du. All right, so I'm going to go ahead and make this substitution. So when I substitute, this will be equal to, actually, let me just write it over here. The substitution here is going to give the integral of 1 over 9 plus e to the x, that's going to become u, and dx becomes 1 over u du. All right. So now we see that we have this term that has it is in fractional form, so it is a rational expression, the denominator factors, so we can use partial fractions. All right, so here we go. I would like to take the term 1 over u plus 9 or 9 plus u, I'll just say u plus 9 times u. All right, and I will write this as a over u plus 9 plus b over u. Again, and if we were to add these two fractions, again, or cross multiplication here, we'll give a times u plus b times u plus 9. All right. So what we have here then is that 1 is equal to a times u plus b times u plus 9. And we get to now choose any value for u where we're going to fix this equation. So you get to choose the value for u that you would like to plug in. Choose a convenient value. I'm going to let u be equal to 0. That would be a good choice here. If u is equal to 0, we get 1 equals a times 0 plus b times 9. So very simply, you see then that 1 is equal to 9 times b, which means b is equal to 1 over 9. All right. All right, I'm also going to let u be equal to, the other annihilator that I would like to use here would be negative 9. So this gives 1 is equal to a times negative 9 plus b times 0. So here we get 1 is equal to negative 9a, which means a is equal to negative 1 over 9. All right. So now that we have a and b, we can go ahead and rewrite our integral. So this means the original problem is going to turn into the integral of negative 1 over 9, this is just a coefficient, over u plus 9 plus 1 over 9 divided by u du. And it doesn't matter what a and b is as long as you are consistent with the way that you originally set it up. A goes with the term u plus 9, b goes with the term u. So this is equal to, we can perform the integration. So negative 1 over 9 is a coefficient, hold it over. The integral of 1 over u plus 9 du is equal to the natural log of the absolute value of u plus 9. All right, plus 1 over 9 times the natural log of the absolute value of u. All right, let's plug back in. This is going to be equal to negative 1 over 9 times the natural log. So remember u, at the beginning of the problem, we let u be equal to e to the x. So this is equal to e to the x plus 9 plus 1 over 9 times the natural log of e to the x. So one simplification that we can make here, do note that the natural log of e to the x is just equal to x. And so finally, I will go ahead and give this answer as negative 1 over 9 natural log absolute value of e to the x plus 9 plus simply just x over 9, or just 1 over 9 times x plus c.